Hi, this is a presentation of static routing as a part of my advanced networking course. When the routers learn about networks, it can be done in two different ways. Either manually, where we manually enter all the routes into the different routers, or dynamically, where the routers learn automatically about the different routes from their neighboring devices. And today we're going to look at how and why we sometimes want to do it manually. And when we do it manually, it's called static routing. There are some advantages of using static routing. First one is all regarding security, because you are more secure because the only routes that are entered into your routing tables are the one that you have done manually. So you have full control over the different routes. The second is that it will not acquire much CPU or bandwidth from the routers because you don't have any automatic updates sent because they are already pre-configured when you set them up, and then there is no need to send routing updates. So there are not that much use for CPU or extra bandwidth to send the updates. And as I said, you know the path to the different networks because you have set them up yourself, so you have full control over the different routes. The disadvantages are, of course, that it takes time because you manually have to set up all the different routes. And of course, when you do that manually, you could also put in different errors. Not, of course, because you want to, but it could happen. And also, if something changes, it's required that you manually implement the changes, and it's not very scalable. If you have a huge network, it's so much job to do every route statically. And of course, if you have a huge network, you have to have a very good knowledge of your entire network if you want to do it statically. So statically, it's something that you normally would use in smaller networks, and of course in networks where you like to have full control. Small networks where you only have one exit to the rest of the network is called a stub network. And if you have a stub network, then it also makes sense to set up a static network. You also use the static routes for default networks. If you want to route something out to the internet, for instance, you don't want to set up all the different networks in the world in your routing table. So then you route to a default network, like the default gateway in your normal network, where you send all information to this address when you want to go outside your own network. And this is called a default route. And normally you use a static route for that purpose. So here is an example. Over here we have a very small network here, which is a stub network, because whenever you want to communicate with other networks over here, well, then you have to go to router 2. So in this case, it could make sense to make a static routes for all networks here in the stub network over here in router 1, since we only have one network that we actually, or one exit that we would like to set it up for. So in this case, when we have a stub network, we can put in a static route for that purpose. If we want to set up a default static route, which means that actually all networks will fit into this description, well, then we will set up a static route for 4 times 0. So 0.0.0.0 means all networks. So if we do that, we can route to the internet, for instance, because of course we don't know all the networks on the internet. So then we say, okay, all networks I don't know of will fit into 0.0.0.0, or we match that IP address. So it's a good idea to use a static route for that purpose. You can also make a summary route. Instead of having here, for instance, if I have 4 or 5 different networks, which begins with 172.2.0 or 20, 21, 22, 23. This is networks that will come in an order which makes it possible to supernet or to make a summary route. And also, if I want to do that, I can do that by using a static route. The reason why I choose to summarize is, of course, so that the entries in my routing table gets fewer, because I would like to have a smaller, as small as possible in the routing table, because that makes it more efficient. So summary routes can also be set up statically. We can also make a floating static route. That means that if I have one static route for my internet connection and I want to have another one to take over in case something happens to that static route, then I make a floating static route. And the idea here is to have a static route with a higher administrative distance than the first one, because it will always choose the route with the smallest administrative distance. So making a with a higher would make it a secondary route and also be the one who be chosen if something happens to the first one. So it's kind of like a backup route. When we set it up, we use the IP route command. You use IP route, then the network you want to route to, and then the subnet mask, and then either the IP address or the exit interface. And we will see how that is done. Because when you set up the next hop options, you set up where, if I want to go to these certain networks, where do I go? Either you go to the neighboring IP address, if you use the next hop as an IP address, or you go to your directly connected interface. So you set up the router's exit interface. And of course here, in this case here, I'm on router 1, and I have this network over here, 172.16.2.0/24. This is this network here. It's directly connected. If I want to go to the network which is called 192.168.2.0/24, which is this network over here, well then I'll go to this IP address on my directly connected network, and I go always, the next hop is always the neighbor's IP address. So in this case it's 172.16.2.2, which is the IP address of router 2's router interface. But then of course I have to do routing twice, because first I say I want to go to this interface, but this is an IP address also, and I need to look into my routing table and see, okay, how can I reach 172.16.2? And then I can see, okay, that is directly connecting. And then I can find it by going out of serial 000, which is the exit interface here. So instead of putting it the next hop IP address, I can just say 192.168.2.0 via serial 000. So instead of putting the IP address of the next hop, my neighboring router, it is actually more efficient to do the exit interface, the serial interface, because then I only have one routing update. So in this case here, make the static route over here and make serial 00 the exit interface. So either you can do it on the IP address or on the exit interface. And if it's possible, it's preferable to do it on the exit interface. Same thing with the static route. You just do an IP route and actually 8 zeros, because this means all networks. 0.0.0.0 for the network address and all zeros for the subnet mask. Every network will match into this IP and subnet mask. So this means all networks. And then again, either here the subnet or the IP address of the next hop router or the exit interface you want to send the information out to. So here you can do an IP route on this one, saying, because this is actually a stub network here, and you can say IP route 4 times 0, 4 times 0, and 172.16.2.2. Then it will be sent all information up here. Or you can do it to serial 000. If you do it on the exit interface, you do it on your own interface. If you do it on the IP address, you do it on the neighbor's IP address. Yeah, and that was a little bit about static routing. Thank you.